G'day and welcome to another one of my videos. I hope this is helpful for you. And we're going to focus on unordered selections this time, and they're also known as combinations. So unordered selections occur when we're choosing from an event and the order is not important. So as I said before, this is known as a combination. So for example, we're looking at choosing 5 players to take the court from 10 players in a squad or a team for basketball. Or we're looking at selecting 6 numbers from 45 in Lotto, or we're looking at choosing 4 students for a survey from a group of 60 people. Now, we're only looking at this for a combination point of view. For an unordered selection, we do know that choosing 4 students out of 60 isn't really a proper sample size and will not be or give us realistic results. So, another one is selecting 2 flavours of ice cream from 20 different flavours. Alright, so we've already seen how to find the number of ordered possibilities. So let's have a look at unordered, and there is repetition in unordered. So I'm going to show you why that repetition occurs and how we can then take that into consideration. So repeated outcomes, they look different, but they're actually the same. So let's go and consider a situation. We're going to have a look at a team of 2 selected from 5 people. And we're going to call, say, those people Anna, Bert, Carl, Donna and Emma. And to make it a bit easier, we'll use A, B, C, D, E. So we could choose Anna first, and then Bert, or Anna then Carl, or Anna then Donna, and Anna and Emma. Well, what we could do is we could actually choose Bert first and have Bert then Anna, Bert then Carl, Bert then Donna, Bert then Emma, and we can continue that having Carl first and then Donna first and then Emma. So what we've got there is all our different possibilities of 2 people out of the 5 to choose from. So there's 20 different possibilities there that we did in our ordered selections in a previous video. But you can see, if you look a bit carefully, that there is actually some repetition. So this team here, Anna and Bert, is the same as Bert and Anna. So it doesn't matter what order they're actually selected, they're the same team. And we can also see there that we've got another team that's the same. And we can continue going through that. So we've got Anna and Donna, and we've got Emma and Anna, and we've got Bert and Carl. So there's quite a few different ones there, and I'm not going to highlight all of them, but there's what we call 2 factorial. That's not an exclamation mark like we do in English. For maths, that's 2 factorial number of repetitions. Okay, so to determine the number of teams that are found, then we would want to look at all these 20 different possibilities and divide that by the number of repetitions. So there are 20 different possibilities, and we actually have there 20 over 2, because 2 factorial ends up being 2 in that denominator there anyway. So we end up with 10 different teams. So the important part when we're looking at unordered selections is this repetitions part, this part down here. And I know I didn't put the 2 factorial like I did up here, because 2 factorial is just 2. But hopefully we'll pick that up as we go through. Okay, now what I did mention before is that this is also a combination, and we can use the NCR button on our calculator just to show you what that looks like with the Casio. That's clear what I had on previously. And our NCR is written in yellow just above the division button, so I'd have to press Shift and that. So I'll just show you quickly. We had 10 to choose from, so we had 5 to choose from, and we're filling 2 positions. So 5, Shift, get our combination and our 2, and we get our 10 different possibilities that we have there. So let me clear that. Okay, so as I said, our 5C2, and we ended up with our 10. So let's have a look at some more examples then. There are 10 players in a squad, but only 5 take the court in a basketball team. How many different teams can be formed from the squad? Now remembering the order that they are selected is not really important. Sure, we have a captain that takes the court, but they're not always on the court because they need to be substituted off and have a rest. So the number of teams that we can do is we can have 10 people fill the first position, 9 in the second position, because I've got 9 people left to choose from as my second player to take the court. I then have 8 players left to select from for that third player. Then I've got 7 to select from for my fourth player, and then 6 to select from for my fifth player. So that tells me the number of different combinations I can have, but remember there's repetition. So I have to take into consideration that repetition, and because we are filling 5 spots in here, or in our team, then what we're going to have down at the denominator is our 5 factorial. Okay, now 5 factorial just means 5 times 4 times 3 times 2 times 1. So if I actually look on my calculator, this Casio has a factorial button just here, and I can press 5 and that, and equals, and 5 factorial, so the 5 times 4 times 3 times 2 times 1 is actually 120. So it's quite useful to have that factorial button so that you can save a little bit of working out time. And when we do that, we end up with 252 different possibility or different teams that can take the court. But again, we can use our NCR button. So if we get our calculator back up, and we've got 10 people to choose from, so let's do our 10 people. Shift to get our C for combination, and we've got 5 spots available on the team, and we end up with our 252 like we did just a moment ago. But a colleague of mine gave me an idea of remembering how to remember whether it's a C or a P, because our calculator also has an NPR. So if the order was important, I'm emphasizing the P, I would use NPR. But because I couldn't care less about the order, I'm emphasizing the C for combination, I couldn't care less, then I'm using my NCR. So that's just a way of helping us to remember whether it's a permutation or a combination. So let's look at another example. In Lotto, we're looking at 45 numbers to select from, and we only want 6. The order that the balls come out, or the numbers chosen, is not important. So we're going to have a look at working out how many different possibilities there are. So in our first ball, I've got 45, all 45 balls to choose from. But once I've chosen that, or that one ball is selected, I then only have 44 balls left to choose for the second ball, and then 43 for the third, 42 for the fourth, 41 for the fifth, and 40 balls left to choose from to fill the sixth position. But remember, the order is not important, so I get some repetition, and because there are 6 balls to choose from here, then this is going to be 6 factorial in the denominator there, and that will help get rid of all that repetition. So we go and work that out on our calculator, and we get 8,145,060 different possibilities. So if I wanted to try and win Lotto and I purchase 1 ticket, then the probability of me winning is 1 in 8,145,060. Odds are against us. But don't forget, we've got our other method of doing this. I couldn't care less about the order. So I've got 45 balls to choose from, and I only want 6. So I do my 45C6, and let's just make sure we get the same answer. So 45, I'm choosing my couldn't care less about the order, and 6, and we get our 8,145,060 as we have already got written down. Now if I'm going a little bit too fast for you, don't forget you can pause it, rewind it, and go as slow as you like. So let's look at another example. We're going to choose 4 students for a survey out of 60 people. Now, as I said before, it wouldn't give us satisfactory results that we could rely on, but we're looking at here unordered selections and how many different possibilities, just as an example. So, as I said, the results wouldn't be valid. Our number of possibilities, well, let's just do our couldn't care less about the order. So I've got 60 people to choose from, and I'm only doing a survey of 4 of them. And we do that on our calculator, and we get 487,635 different possibilities. And let's have a look at another example. You go to an ice cream store, and they've got 20 different flavors to choose from. You want 2 scoops, and we're going to select 2 different flavors. How many different ways can we have those 2 different flavors? Do I care which order they come in? No. So I couldn't care less about the order, so I'm doing a combination. And so I've got 20 to choose from and 2 flavors that I'm having. And when we do that on our calculator, we can have 190 different ones. Okay? So I hope you've found that useful, but what you really need to do now is to practice, and then practice some more, and practice again, because just like in sport, the more you practice, the better you become. So I hope you've enjoyed this video, and good luck with your work from now on.